lot of this should be review. Actually, today and tomorrow we're all in this booklet, and they're all review of grade 11. You just might not remember it, but they're all review of grade 11. We don't use SOHCAHTOA in grade 12 anymore. We use sine y over r, x over r, and y over x for tan, because you're looking at something on an actual xy coordinate plane. So the way that people have remembered it, this one someone told me once, was sign your resume. To remember that sine is y over r. Sign your resume. That one is the only one that's going to make remote kind of sense. The rest are a little bit ridiculous, as if that one is super awesome. This one is tan your Xbox. I don't know. It gets cold in the winter. So tan your Xbox. And the middle one's even worse. Just so you know, you can thank Sebastian Nowak for the middle one, because we couldn't come up with anything. So this is what he came up with. Cook extra rice. Hey, the guy had something. I couldn't come up with anything. That was pretty good. That's extra. Hey, let it go. Let it go. I'm singing on the thingy. I just realized that. Awesome. Good times. So sign your resume, cook extra rice, tan your Xbox. They're wonderful. I know. Just remember that. Okay. So the other thing we need to remember about the unit circle, the points are x, y, right? X is always cos. Y is always sine. So the coordinates on the unit circle are cos and sine always. So if I ask you of cos of an angle or sine of an angle off the unit circle, it's really easy. You just literally pick the x value off the unit circle if it's cos, and the y value off the unit circle if it's sine. Now if it's tan, this is the good thing. You have a formula sheet. Use it. A lot of you are sitting there like throughout the test crying because you can't remember which is. You have unit circle. If you unit circle, you have a formula sheet. So tan is sine over cos, right? What's sine always? Y. What's cos always? X. Tan your Xbox comes from that as well. So y over x. So if you actually want tan of a degree, you're going to have to divide these two. You're going to have to go sine divided by cos. You're going to have to go y divided by x. Okay? Then we have our other trig ratios. We have cosecant, secant, and cotan. Cosecant and secant aren't bad. Cosecant goes with sine, and secant goes with cos. They're easy to remember because the c goes with the s and the s goes with the c. So cosecant goes with sine, secant goes with cos. So it's 1 over cos. Now let's think about this. If my coordinate was 1/2, so if I did cos of 30, nope, if I did sine of 30, sine of 30 degrees is the y value at 30 degrees, right? What's my y value? 1/2. Do you see why the unit circle is helpful? It's right there. So sine 30 is 1/2. Okay? If I gave you, okay, but I want cosecant of 30. Cosecant of 30, cosecant is 1 over sine. So it would be 1 over 1/2, which is the same as saying 1 divided by 1/2, which is the same as saying 1 times 2 over 1, which is the same as saying 2. That is a lot of work. All you need to remember is that cosecant is the reciprocal of sine. Reciprocal means flip, right? So if sine of 30 is 1/2, cosecant of 30 is 2 over 1. So if sine of 45 is root 2 over 2, cosecant of 45 would be 2 over root 2. If sine of 150 is 1/2, cosecant of 150 would be 2 over 1. You literally just take what's there and flip it, because they're reciprocal identities of each other. Okay, reciprocal means flipped. All right, so it's review of last year, plus we're adding cosecant, secant, and cotan, which makes it a little more difficult. So here we have that. Cosecant is 1 over sine, or r over y. Please don't make up, you can make up new acronyms if you'd like, but it's just literally sign your resume. So cosecant is resume your, if you were to do that. be silly. Just write sine and what it is, and then just flip them for cosecant. Cos is y over r, or x over r, sorry, so secant is r over x. And cotan is y over, or tan is y over x, so cotan is x over y. They're just flipped. Now, cast rule you learned last year. Cast starts in quadrant 4 and goes counterclockwise. You learned cast last year. That looks like an O. It is not meant to be an O. It's a C. Whatever letter is there is positive there, okay? So if C is here, cos is positive here. If S is here, sine is positive here. If T is here, tan is positive here. Indirectly, the other ones are negative there. So if cos is positive here, sine and tan are negative. If tan is positive here, cos and sine are negative. If sine is positive here, cos and tan are negative. Everything is always positive in this first quadrant. So sine and cosecant work together as well. So sine's reciprocal is cosecant. Tan's reciprocal is cotan. It's easy to remember because it's tan and cotan. And then cos's is secant. Those are the reciprocals. They follow the same rules. So if cos is positive here, it's reciprocal secant is positive there. If sine is positive here, it's reciprocal cosecant. And tan is positive here, it's reciprocal cotan is positive. Okay, so they just follow the same rules. So that's just your cast rule with the reciprocal identities added to it. You learned cast last year. Okay. So when you're given a point, and you were asked nothing of that point, just you're given a point, what's the only thing you can do with the point? Draw it. So let's do that first. And then we'll actually ask ourselves the question. So you see a point, draw it. It's at -2 and -6. And if your teacher had given you that lovely point exercise I was talking about earlier, you guys would be rocking at this. So I hope that you can do it without the super fun exercise. Okay. So -2 and -6. You have a point. Okay, so the very minimum, we drew a point. -2, -6. Here's the question. Up here, example 1. Given the following point on the terminal arm of some rotational angle, so that point's on the terminal arm. Terminal arms always start at 0, 0, right, and work their way out. So let's draw that. That point is on a terminal arm. Whoa, that's bad. Just pretend that's a straight line. Okay? Find the exact value of the 6 trig ratios. You used to have 3, you now have 6. You have secant, cosecant, and cotan as well. So you have 3 more trig ratios. Great thing about them is they're literally just take the first 3 and flip them, and you have the next 3, right? So it's not super hard. However, if you get the first 3 wrong, you're going to get the last 3 wrong, which makes it a little bit problematic. Okay. So find the exact value of the 6 trig ratios and the rotation angle to the nearest degree. Rotation angle is going to be this angle in here. So from here to here, they want us to find it, right? What we always do is draw the point and make yourself a triangle. 90-degree triangle. So we have our 90-degree triangle here. Do we know anything about the side lengths or anything about that triangle? We know that this side length is -2 because it moved me 2 over. We know that this side length is -6. How could we find the third side length? Starts with a P, rhymes with Pythagorean theorem. Let's go. Pythagorean theorem, yes. That is what it is. So we're going to use it and we're going to find it. We're missing the hypotenuse, which is also the radius, right? We're missing that R value. So we have R squared equals X squared plus Y squared. That is Pythagorean theorem with a unit circle. Because your 2 side lengths are X and Y, and your hypotenuse is your R. So we're going to have R squared equals -2 squared plus -6 squared. R squared equals 4 plus 36. R squared equals 40. Square root of this. And R equals plus or minus root 40. Your radius is a length. Lengths cannot be negative. So radiuses will always be positive. So the great thing is if you forget the plus or minus sign, you're not hooped for this case. You are if you're finding x and y. We kick out the negative. Worst thing you could do, turn this to a decimal. Do not turn this to a decimal. We are not in grade, I don't know what, but do not turn this to a decimal, okay? We use exact values because it says exact value means not decimal. Root 40, how can I break it down? Root 40, you could break down into root 4 times 10. When you take that 4 out, what does it become? A 2. So you get 2 root 10. So you're going to get r equals 2 root 10. So we can write that side length as well. And you know what I do to make my life a little easier? I label these. So this is my y, because it's along my y. This is my x. And once they're labeled, my 6 trig ratios aren't hard to write out. So up here, I'm going to write out what my six trig ratios are. Sign your resume. So sine theta, y over r. Cook extra rice. Cos, got a little T on that one. Cos theta. Don't forget the theta beside this. It needs to have an angle measure beside it. You can't straight sine. Cos theta equals x over r. Tan your x box. Y over r. Y over x, because that's your x box. Good job. Then they're reciprocal trig ratios. So sine goes with cosecant. That's a CSC. And it's y, r over y. They flip. Cos is secant. R over x. Tan is cotan. X over y. We have x, y, r. It's not hard to find now to do the rest of the 6 trig ratios because you have them. However, you're going to have to do some reducing. What I would do, because you don't have a lot of space, is so, or you can do this. I'm just going to skip this one and go to 3. You can skip that too. The other one's fractions, so we don't want to skip the fraction one. So you're going to have sine theta equals y over r. Y is -6. R is 2 root 10. We can't keep that root 10 in the bottom. We have to rationalize it always. So we're going to get multiplied by root 10. You don't have to multiply by the 2 when it's just a monomial, one term on the bottom. So you're going to get -6 root 10 over 2 times 10. Because root 10 times root 10 is just 10. So it's going to be 2 times 10, which is 20. And then you have to reduce it. Take a 2 out, and you're left with -3 root 10 over 10. Now, when people do cosecant, they'll go from this answer and flip it, and then you're back to having this root on the bottom and a mess. Don't. Use your actual answers, because if you use your answers right off the top here, this 2 root 10 is going to actually be on the top now. You're not going to have to rationalize anything. So cosecant theta is r over y. So it's going to be 2 root 10 over y, which is -6. And then you can reduce them. Where did my negative go? Oh, there it is. You can reduce them, and you're going to get a 2 out of both. And you can only take it out of the coefficients. You can't cross a 2 out of the radical. Can't do that. So it's going to be -root 10 over 3. Often they're going to move the negative up. Cosecant, or cos, I guess I should do. Cos theta, cos theta equals x over r, right? X is -2, r is 2 root 10. Now you could cross those 2's off right off the bat if you'd like to. You can go like this. And you'd have negative 1 over root 10, but you're still going to have to rationalize the denominator. So you're going to get negative 1 root 10 or negative root 10 over 10. That can't reduce because you can't cross off radicals and numbers on the bottom. And secant, I'm going to do r, which is 2 root 10, over x, which is negative 2. These reduce. And it's going to be root 2 over negative 1, which they'll never write it that way. They'll write it as negative root 10. Root 10 over negative 1, like this, they'll bring the negative up and write it as negative root 10. They'll never write it like that. Tan is y over x. Y is negative 6, x is negative 2. So it's going to be 3. And cotan is going to be x over y, which is negative 2 over negative 6, which is a third. Those are your 3 trig ratios. Those 3, and then there's these 3. Oh, I didn't box this one. So your 6 trig ratios, your 3 normal and 3 reciprocal. You did do the 3 trig ratios last year where you were given a point and had to come up with the 3 basic trig ratios from a point. You also were given a point and had to come up with the rotation angle. You can use any of these to come up with the rotation angle. Any of the 6 trig ratios you can use. I wouldn't use the reciprocal ones just because it makes it a little harder to punch in your calculator. We need to find out whatever the heck this angle is. When we find out what this angle is, what can we do to get the rotation angle? Once we know this is the angle, it's a reference angle, we can add it to 180 and we have the whole rotation angle, right? How can we find that angle? Well, doing the negative of all inverse of any of these will get me theta, right? And I just want theta. Theta is this little angle in here. So if I do the inverse of any of these, it will get me theta. Now, normally if it asks me for the rotational angle, it's going to give me a restricted domain. If the restricted domain is in degrees, then you have to have your answer in degrees. If the restricted domain is like between 0 and 2 pi, your answer has to be in radians. Okay? You can always find it in degrees and convert it to radians if you want. I'm going to find it in degrees. So I'm going to use, for ease, tan theta equals 3, because that's the easiest one. I'm not typing in root 10s or anything like that, right? So I'm going to use tan theta equals 3 to find my rotational angle. Tan theta equals 3. I want theta. How do I get that tan to go away from that theta? Once I know theta, I can add 180 and I'm done. How can I get that theta? How do I get the tan to go away? Anyone? Yeah. Yeah, the inverse of tan. So I'm going to go tan neg 1 both sides. Now, the catch. What button are you pushing in your calculator? Second tan, right? The moment you touch that tan button, the cos button, or the cosecant button, the moment you touch any of those 3 buttons, you need to think, what mode do I want to be in? So I want to be in degree mode, because even if I want this in radians, I can convert it after, right? So I'm going to go to mode, and I'm going to make sure my calculator's in degree mode. If it's in radian mode, you're getting the answer in radians. If it's in degree mode, you're getting the answer in degrees. Okay? So the moment you touch any of those 3 buttons, I'm going to touch that button. I need to think, what mode do I need to be in? The moment you go to touch that button. Okay? If you're not touching that button, doesn't matter what mode you're in. So if you're in degree mode now, go second tan 3. Oh my calculator. What'd you get? I got 1.2490. Did you get that? Why did I get that? Come on. I'm in radians. Do you know what they're going to have for an answer? 180 plus 1.249. So they're going to have 181 as an answer. And if you have your calculator in radian mode, it will be there. They will always have the answer on your diploma to if you are not in the right mode. So you need to think, what mode do I need to be in? Okay, they will always have that answer there. It's the top picked answer because it's the top error. So mode, and then go to degrees, and secant tan of 3, and I get 71.5. Okay, so I'm going to do 72. I'm going to treat theta as 72. So equals 72 degrees. Now, what is my rotational angle? How do I find it? How far is it from here to here? 180. How far is it to here? 72. So 180 plus 72 is 252. So what's my rotational angle? 252. 180 plus 72. Go to a separate sheet of paper, and I'm going to get you to try 3 and -4. Go to a separate sheet of paper, because if you need to try 3 and -4 before you try fractions, trust me.